All right, we're still in section 4 of chapter 4, and last time we talked about just factoring those equations that were expressions at the time, the ax squared plus bx plus c. Now we're actually going to move to the next step of actually solving an equation. I'll give you the quick steps and then I'll show you how to do it. So if we're solving a quadratic equation, the first thing we need to do is it needs to be in standard form. Standard form, remember, is this ax squared plus bx plus c equals 0. So just get the 0, or get all of the terms on one side so that 0 is on the other side. After you set it equal to 0 and get the standard form, you're going to factor the left-hand side of your equation. Then, if you'll remember what we did before when we didn't have a coefficient of x squared, is we set each factor equal to 0, simply because if something equals 0, that means you multiplied by 0 somewhere to get that 0. So we'll set each factor equal to 0 and solve. And that's it. So here we go. 4x squared minus 17x minus 15. The first step is to get it into standard form, and this one is already in standard form. So the next step is simply to factor it. So let's just factor it just like we did before. Why don't you pause and factor it? That'll be a good review from last time. Pause and factor it on your own. Because when you factor it, you should get 4x here and x on this side, and the 15 is going to be 3 and 5. So either 1 and 15 and 3 and 5, and it does actually come out to 3 and 5. 4 times 5 is 20. You want that to be negative. 20 minus 3, that one would be your positive term to get negative 17x. So once you get your factors, now 4x plus 3 times x minus 5 equals 0. So our zero product property says that one or the other of these has to be 0 in order for the product to be 0. So what we'll do is we'll set each of them equal to 0. Because one or the other of them does equal 0. And then just quickly and easily solve those like you should have already learned how to do in Algebra 1. Subtract 3 from both sides. 4x equals negative 3 divided by 4. So x equals a negative 3/4 is one of your solutions. Add 5 to both sides. X equals 5. So your two solutions are 5 and negative 3/4. All right. This next one actually has the first step in it. We need to put this into standard form, and you can see that, oh, it's not equal to 0. So we need to put it into standard form. All you need to do is move move your terms over all onto one side, and you do that by simple algebra. So you're going to add the 14y to both sides. So you're going to match it up with the term here, and you can go ahead and add the 48 at the same time. So now we're going to have 3y squared plus 36y plus 108 equal to 0. And go ahead and pause me for a minute and factor this on your own. You should be able to do it by now. Because the first thing you're going to do, so now when you come back, hopefully you paused it and did it, and now you have an answer. So I'll do it quick. You should have factored out a 3. Y squared plus 12y plus, oh, is that 36? Yep, 36. That's going to equal 0. So now this one, don't lose your 3. You've got y and y. This is a perfect square, isn't it? 36 is a perfect square, so let's test that. Let's see if, did you recognize that or did you work it out? So 6 times 6 is 36, and 6 plus 6 is 12. So 3 times y plus 6 squared is equal to 0. And now, so when we do this product property, the zero product property, and set each of the factors equal to 0, well, 3 is not going to be equal to 0. So that one's not one of our solutions. x plus 6 equals 0 or x plus 6 equals 0 is going to be the same. So just set x plus 6 equal to 0 and solve. So x equals -6 is your solution. And in this case, the two solutions are exactly the same, so there is only one solution. So go ahead and work this one while I erase the board. Work that one on your own. We'll do one more together. And then we'll work on word problems because you love those so much. Hopefully you already have it written since I'm standing right in front of the problem. All right, so you know the first step is to get it into standard form. So you're going to subtract x from both sides, and you're going to subtract 8 from both sides. So now we have 12x squared plus 6x minus 6 equals 0. Hopefully you got that. And then you look to see 12, 6, and 6. Those all have a 6 in common, so pull a 6 out of there. 2x squared plus x minus 1 equals 0. And your 1 is squared, but your 2 is not. So you're going to have to 2x times x. And it should be easy because 1 and 1, 1 times 1 is 1. So now your signs are different and you want them to be positive. So you want the 2 to be positive and the 1 to be negative. So now you end up with 2x minus 1 equal to 0 and x plus 1 equal to 0. Solve both. So add 1 to both sides and divide by 2. So x equals 1/2. And subtract 1 from both sides, x equals -1. So you should have gotten those. If you didn't get those, or if you're not quite sure, go ahead and go back to the examples, rewind the video, maybe look at section, at the section right before this one, the first part of section 4 of chapter 4. Because we're going to move on. Because I have, you always say, when would we ever use this? Well, here we go. If you are designing a garden and you want this garden to be a rectangular flower bed with a stone border that's uniform, so the same size all the way around, you know that the flower bed is going to be 22 feet by 15 feet and your budget allows 120 feet square of stone. You want to know what is the width of your border. So you want to start out with a picture. So this picture is going to be a rectangle. And you're going to have a flower bed inside a border. Your border is uniform all the way around, so each of these is going to be X. And you know your flower bed is 22 by 15. So 22 is this direction and 15 is this direction. So if you want to find how wide your border is, we're going to have to come up with an equation that's going to show this rectangle, the area of the rectangle, and take out the inside. Well, that'd be easy if we knew what it was. Well, let's put some numbers with it. So the width is 22, but it's 22 plus x here and another x here. So it's going to be 2x plus 22. That's going to be our length. Our length times our width gives the area of a rectangle. So the width is this 15 plus this x plus this x. So you've got 2x plus 15. So that gives you the area of the entire rectangle. But you don't want stone on the whole rectangle. That would not be very, very pretty flowers. So you're going to subtract out this part that's in between. If you take the 15 times the 22, you will find that that is 330. So you're going to subtract out 330. When you subtract that out, you want to end up with 120 square feet left around the edges. So that's where you get your equation that looks a little bit daunting, but it's not nearly as daunting as all these words, right? So let's multiply it out using FOIL. 4x squared plus 30x plus 44x. Don't let me do it all by myself. All right, you be doing this. See if you can beat me. Because here we go. 22 times 15, what did I say that was? Oh, 330. All right, so that's FOIL. That's all of those minus 330 equals 120. Well, that's handy dandy. The 330 minus 330, that's going to go away for us. So 4x squared plus 74x equals 120. So now we have quite a simple equation. So now we go back to the steps. We've got it in standard form. Now we simply need to factor it. Oh wait, we didn't get it into standard form, did we? Is that what we need to do? Sure enough, let's get it into standard form. Subtract the 120 from both sides. So 4x squared plus 74x minus 120 equals 0. Now we have an equation that is in standard form. Now we simply factor it. Will 4 go into all of those? Will 4 go into 74? Nope, but 2 will. So 2x squared is what's left, plus, what is that, 30 what, 32? Oh man, 37. And 60 is half of 120. So now continue factoring, don't lose your 2. 2x is just, or 2x squared is 2x times x. 60 has a lot of different things we want to subtract, or the last term is negative, so we're going to have one positive and one negative. Turn it off and come up with them, because I already did the work, so I'm just going to look at it. All right. Did you do it on your own? All right. 3 times 20 is 6. 20 times 2 is 40. 40 minus 3x is our 37x. That equals 0. Can you solve it from here? Can you get an answer? Each of these equal to 0. So 2x minus 3. We're going to ignore our 2 because 2 can't be 0. All right. 2x minus 3 equal to 0. And x plus 20 equal to 0. Solve each one. Plus 3. Divide by 2. There's one possible solution. Subtract 20 from both sides. X is negative 20. Now remember, this is a word problem. So now that we have answers, we've got to make them real and put them into the problem. So the problem said, what is the width of your border? Well, we either have 3/2 or negative 20. A border cannot be negative. So we know that 3/2 is going to be our border, and 3/2 is actually 1.5. So x is 1.5. 1.5 feet is how large our border is. All right, one more thing. Hang with me, because now we're going to be talking about maximums and minimums. When we're dealing with business type problems, there's times when you want to get the most bang for your buck. If you sell a product, if you raise the price, you're not going to sell quite as many, but you're going to make more money for each item that you sell. So this type of problem deals with minimums and maximums of our parabola. If you have, all right. If you have a parabola, let's go back to our formula. Our intercept formula. So remember, in our intercept formula, the P and the Q are our zeros. So that's where the parabola is going to cross that x-intercept. So maybe like this, or maybe somewhere else, wherever it is. Those two x's are where it crosses the those two zeros are where it crosses the x-axis. And if you'll remember, a parabola is symmetrical. So there's going to be a line. Our line of symmetry goes right through there, and because of my artistic ability, you can't really tell, but that's supposed to be symmetrical. And So you know that the maximum value or the vertex in this equation is going to be halfway between these 2 points on the x-axis. So if you can find your zeros, then you can find where on the x-axis that maximum or the minimum, if it's a parabola that's going downward, where that minimum value is going to be. All right, so what we're going to do is this. If these are your zeros, if you take your zeros and add them together and divide by 2, then that's going to give you this value here, which is the place where your parabola will be at its maximum. All right, so let's do a problem that involves maximums. This is the type of problem that looks like this. So an internet service provider sells high-speed internet service for $30 a month to 1,500 customers. For each $1 increase in price, the number of customers will decrease by 25. How much should the company charge to maximize monthly revenue, and what is the maximum monthly revenue? So what's happening here is exactly what I said before. Every time the company increases their prices, they lose customers because the customer says, oh, I can go somewhere else and get, or I don't really need high speed, I'm just going to go with low def, that type of thing. So every time they found that every time they increase their price by $1, they lose 25 customers. So they want to find out, okay, I do want to increase my profits. So every time I increase my, my price, the profit increases, but I have to figure in how many customers I'm going to lose at the same time. So what we're going to do is this. We're going to take the number of, let's see, we've got to multiply the $30 a month, the 1,500 customers, to get our total revenue. So our total revenue, we're going to call it a revenue form, or a revenue function. Our total revenue is going to be the 1,500 customers minus 25 times however much we increase our price. So X is the number of dollars that we increase our price by. And every time we increase the price, we're going to lose 25 customers. So that's where the 1,500 minus the 25X comes from. But when we do that, we're going to take it times the price. So the price was $30, and we're going to add X to each of those. So now what we want is, we could multiply all this out and figure it out, but what we could also do, remember that formula is the y equal, finding our, to find our zeros. Let's see if we can put it in this type of formula, and then we can find our zeros quickly and easily. So let's see, 30 plus X, that part's easy. That's just X plus 30, right? That looks like one of our X's right there. This 1,500 minus 25X, the X is negative, so we want to take out, let's take out 25 and have X minus, so now if we're taking out negative, that's positive, but if we take out a negative here, now it becomes negative because a negative times a negative becomes our positive. All right, and so when we divide that 1,500 by 25, we have X minus 60. So now, so we've got 25, negative 25 times X is negative 25X. Negative 25 times the negative 60 gives you your 1,500. So now we've got this in this formula. So we just need to find our P's and our Q's. So we've got 60 and we have negative 30 are our two zeros. And remember, those are the places where the parabola is going to cross that x-axis. So if we can find halfway between 60 and 30, that's going to be the place where the parabola is going to turn. It's going to be at the very top, at the vertex. So we just take the 60 plus negative 30, divide by 2. It's 30 over 2, which is 15. Okay, so now $15 or $15 is our max. What does that represent? So is that our final answer? $15 is our X. So remember, $15 was the number of, that's the number of dollars we added. Is that part of our problem? So now we got to go back to the problem and find out what is it that we're being asked. How much should the company charge to maximize monthly revenue? So they're going to charge this $15, but remember they were already charging $30. So you're going to take your 30 plus the 15. So they need to charge $45 a month. So that's the answer to your first problem. If they charge $45 a month, that's going to be they're going to make the most that they can possibly make per month. So what is the maximum monthly revenue? Well, now we've got to put that into our original equation and say, well, $45 is how much we're going to multiply by, but we've got to subtract out our number of people. So you're going to have the 1,500 minus 25 times 15 times 30 plus 15. All right, whoops, let's do brackets here. So when we take 25 times 15, oh dear, I did it here. I don't have you here to do it for me. So 15, 375. So 1,500 minus 375 times our 45. That should end up being $50,625 is what they're going to make every month. Not bad. All right, so you'll be doing some problems with minimums and maximums. You'll be solving regular equations. I think you should just go to it. See you soon.